Hi, this is Maggie. In this video, we're going to talk about the mixin pattern, which is a multiple inheritance pattern with some rules that help mitigate conflict issues that can result in multiple inheritance, and that is a very useful pattern. If you haven't already watched the videos on multiple inheritance, I recommend you do so. I'll link the first one here and also in the description. It would also be helpful to be familiar with the observer pattern, so I'll include a link to a video about that pattern in the description. This is listing 7.3 from Objects and Games with Python, and we're going to start by running the program. So you can see a graph depicting projectile motion, and you also see some text which tells us 30 degrees and 100 meters per second. Basically, there are two different kinds of observer classes here that are showing us information about a projectile. Now I can click the A button, and now I'm in a mode in which I can change the angle by pressing the up and down arrows. So I'll press up some, and you can see both views changing. I'll click down, and again they change. Now I'll click the V button, and now I'm in a mode to change velocity with the arrows, and I'll press up and down again. So you can see both views change. You might remember that we can use the observer pattern to keep object states synchronized, as you saw in the example, with the text and graph output synchronized with the projectile data. But what if the observers belong to several different classes, as we see here? One observer is a graph, and the other is text. We are then faced with the decision to use multiple inheritance or one of the alternatives to multiple inheritance, such as duplicating the observer code in several different classes or having an observer as a component of each of the classes. An observer is an interface that is presented to the outside system, in this case the subject, and the subject must communicate with all of its observer objects through that interface, the update message, without knowing the runtime class of the observer objects. This is therefore a candidate we should consider for multiple inheritance. Here we can imagine a graph observer and a text observer. One pattern that is used to mitigate some of the conflicts that can arise with multiple inheritance is the pattern of creating mixin classes, which are abstract classes intended to be used as superclasses in multiple inheritance hierarchies. When mixin classes are used, a subclass inherits from one or more mixins. The subclass may or may not have its own attributes in addition to those inherited from the mixin components. Grady Booch, one of the fathers of UML, suggests that mixin classes do not have a superclass, are usually combined with classes with a completely independent set of responsibilities, and are usually intended to augment another class. An observer meets these requirements well. Let's take a look at the implementation. The observer mixin class is pretty straightforward since we're implementing a pattern we already know. Remember that the observer, if it's a mixin, will not have a superclass other than object in Python. It will have a reference to its executor or subject, the object it's observing. And it will have an update message that the executor will send it whenever it changes. In the implementation of the observer class, the initializer takes the executor as a parameter and also kwargs, as we expect this class to be part of a multiple inheritance class hierarchy, and we want to allow other parameters to pass through this method to the next initializer. Within the initializer, we invoke the superinit method, set the executor field, and attach this object as an observer to the executor. The update method is simply pass, as it will be implemented in subclasses. Let's look at the subject class, the projectile class, which represents the projectile that the two observers will be displaying information about. The projectile class is responsible for maintaining the initial velocity and angle of a projectile, and it is responsible for allowing changes to the initial velocity and angle by processing key presses. The projectile class will maintain the initial velocity and angle of a projectile. It has two fields to store the projectile data, velocity and angle radians. It is initialized with these values as parameters. There are two accessors that allow access to the angle and velocity values. There are also accessors that return flight time, maximum height, and horizontal range, calculated from the velocity and angle. These accessors are not used in this program. The projectile class has one field used to fulfill its responsibilities in the subject role of the observer pattern, the list of observers. It implements the expected subject methods attach, detach, and notify. The rest of the class allows modification of the angle and velocity values through key presses. Now let's look at the two synchronized views where the multiple inheritance comes into play. The easier but less fun class is the text view observer view, which displays the projectile's angle and velocity in text on the screen. We'll look at this class first because it is simpler, allowing us to focus on implementing multiple inheritance with our observer mixin class. For the text view observer, there is a text view superclass that displays information to the screen as text. The class could be quite general, but to keep it as simple as possible, we will use a default font size and color, and allow customization of the text that is displayed and the location of the text view. It has a draw method responsible for blitting the text surface to the parameter surface. Because this is part of a multiple inheritance hierarchy, it invokes the superclass initializer and passes the kwargs parameter to the initializer. We then subclass both text view and observer to create the text view observer, which will change the text being displayed in response to an update message. You may recall that the update message in the observer mixin is not implemented, as how an observer updates is dependent on the subject and the responsibilities of the observer. The text view observer class inherits from both text view and observer in the class definition. We pass the kwargs parameter to the initializer and invoke superinit in the initializer. This will ensure that both superclass initializers are invoked, as they are both also written to take the kwargs parameter and pass it along to the super initializer. The work of attaching to the subject is handled by the observer superclass initializer method, and the work of drawing the text to the screen is handled by methods in the text view class. The only work required of the text view observer is updating the text when initialized and in response to an update message. Many of the responsibilities of the text view observer are handled in its superclasses, with only a little work done to synchronize what is displayed with the projectile object. The projectile plot and plot observer classes follow the same pattern. The work of drawing a plot of projectile motion will be done by the projectile plot class, and the plot observer class will synchronize what is displayed by the projectile plot methods to the state of the projectile. The projectile plot class will therefore be responsible for drawing a plot showing the XY coordinates of a projectile over time, from the time it is launched to the time it returns to its initial height, or reaches the ground if the ground is level, given a particular initial velocity and angle. In this implementation, we have the projectile plot maintain a surface, which is the drawing of the plot. Each time the plot observer receives an update message, it obtains the new initial velocity and angle from the projectile and sends itself the update plot message. In the update plot method, the projectile plot erases the surface, redraws the grid, and then draws a new representation of the projectile's motion on the grid. When the plot observer receives the draw message, implemented in projectile plot, it blits its plot surface to the parameter surface. In the main program, we create the projectile, text view observer, and plot observer objects, and process key events by sending them to the projectile. We then draw all of the views. The observer pattern handles the work of informing the views when the projectile state changes as a result of a key command, so there is relatively little code in the main function. In the projectile program, we considered a multiple inheritance solution because we needed to provide the observer interface in classes that otherwise had very different functionality. We therefore created an abstract observer mixin class that we could use as a superclass for a variety of classes in different inheritance hierarchies. In Python, this is not strictly necessary because Python's dynamic typing allows for a dynamic check of whether an object implements a particular interface. In other words, Python checks at runtime whether an object can respond to a message that it is sent. We could, in Python, add the update message to any class, whether it derived from observer or not, and we could then treat it like an observer. However, using a single superclass ensures that we are consistent in the way we write the observer methods, which reduces the chance for errors. My goal here is to present object-oriented design in a somewhat language-agnostic way that illustrates principles and not implementation details for one specific language. If we implemented this design in a programming language with static typing, then it would be critically important that all objects implementing the observer interface were members of the same class, and so multiple inheritance might be the best solution. It should also be apparent that a multiple inheritance solution must be designed into the superclasses through their acceptance of a kwargs parameter that they pass to a call to a super method in any method that will be overridden. Multiple inheritance is not a design decision to be taken lightly because of the potential conflicts and somewhat unintuitive implementation. I hope that you found this example helpful. Design patterns are based on years of experience and are an excellent starting point when you have system requirements that can be met by a pattern. If you're venturing into a multiple inheritance solution without a pattern for your guide, proceed with caution.